Hello, and in this video I will be showing how to solve the problem 24 from the 2012 F equals ma exam. In this problem we have 3 point masses m and they are attached together by identical springs. When this whole system is placed at rest on a table or some horizontal surface, they form a triangle, each side initially having length L, like this. But then we take this whole assembly and we start spinning it at angular velocity omega, and this causes these springs to stretch out and form side lengths 2L. So this is what our system kind of looks like when it is in motion. And we are supposed to find the spring constant of each of these springs. So first thing I'm going to do is draw a free body diagram. The exact decision of which mass we use does not actually matter because of symmetry. Each mass is effectively the same. And each mass feels two forces, Fs, from both springs attached to it. And this angle theta right here is equal to 30 degrees because this is an equilateral triangle, so each of these angles is 60, and this bisects the angle, so this must be 30 and 30. So this is our entire free body diagram, and we now know that Fs is equal to minus kx from Hooke's law. And x is the amount that the springs are stretched, right? And you can see here that we start at length L, but then we end up at length 2L, which means our springs were stretched by length L. So the force here is actually equal to minus KL. Writing out F equals ma, or rather ma is equal to the sum of forces. Our acceleration is equal to omega squared r, because that's centripetal acceleration, we are rotating it, where r is the distance from the mass to the point of rotation, so the center of here, and we'll find that out later. And that's equal to the sum of forces acting on the mass. So in this direction, or in the direction of this acceleration, which is radial, there's two forces. So 2 times F of s cosine of theta, right? And m omega squared r is equal to 2 times, I'm going to get rid of the negative sign here because these forces are acting in the exact same direction as the acceleration, so we can get rid of the negative sign. KL cosine of theta. Cosine of theta is equal to root 3 over 2 because theta is equal to 30 degrees. So m omega squared r is equal to 2 times root 3 over 2 k times L. We have to now figure out what exactly r is, so I'm going to go to this diagram, and I'm going to draw a right triangle right here. And the side of this right triangle is equal to L, and the length, or the hypotenuse of it, is equal to r. So you can see here that r cosine of theta is equal to L, which means r is equal to L over cosine of theta, and cosine of theta is equal to root 3 over 2, as we saw here, which means r is equal to 2L over root 3. We can plug that in here. M omega squared 2L over root 3 is equal to root 3 k times L. Now we just solve for k. So we can first multiply by root 3 on both sides, so this becomes 3. We can cancel out L, and now we can see that k is equal to 2 over 3 m omega squared. And this is the answer. This corresponds to answer option C on the test, which is the correct answer. Thank you for watching this video, and see you next time.